Okay, so today's lesson, we're going to be going over solving proportions. So in the lesson we did before on rates, this is just an extension of that where we will be using multiple rates in the same problem. So here's a little intro problem. It says a local department store advertised a sale as shown at the right. Gotta love nail polish. It says write a ratio in simplest form that compares the cost to the number of bottles of nail polish. So I'm told to write a ratio, which is just a rate. I'm comparing the cost to the number of nail polish. So you see they have a sign here. These are on sale, 2 for $5. So again, if I'm comparing the cost to the number of bottles, I put the cost in the numerator, I put the number of bottles in the denominator. So for this problem, the cost was $5, and the number of bottles was 2 bottles. So this would be a ratio comparing those two prices. Now when it says put it in simplest form, we could either leave it like it is, or we could work this into a unit rate. So if you'll remember from the lesson previous, a unit rate must have a denominator of 1. So since the denominator is currently 2, I would divide by 2 on both the top and the bottom. 5 divided by 2 is 250, and then 2 divided by 2 is 1, which means it's going to cost me $2.50 for 1 bottle of nail polish. Now, problem 2. Suppose Kate and some friends wanted to buy 6 bottles of polish. Write a ratio comparing the cost to the number of bottles of polish. So I would take this unit rate, $2.50 for every 1 bottle, and I know they now want to buy 6 bottles. So I would want the denominator to be 6, so I would multiply by 6 in both the numerator and denominator. Again, in the denominator, 1 times 6 gives 6 bottles, which is what we are looking for. And then 250 times 6, that would be $15. So it costs $15 for 6 bottles of nail polish. Now I want to know, is the cost proportional to the number of bottles of polish purchased? And then explain. So this is what we're going to be looking at today, is proportional. So 2 numbers are said to be proportional if they can reduce to be the same fraction. So 250 over 1, can this reduce back to that same fraction? Well, yes, it can. If I divide it by 6, because again, I just multiplied by 6 on top and bottom to get there. Now, if I divide by 6 on top and bottom, I reduce it back to the same fraction it was before. So when we're working with proportions, we're going to be having fractions that reduce to the same thing. So again, for today, we're going to be given fractions that are equal to each other, and we call that a proportion. A proportion is an equation stating 2 ratios or rates are equivalent. So for instance, right here I have the fraction 6 over 8. If I reduce that, I would get the fraction 3 over 4. So it turns out these 2 rates are equivalent, so we could set up a proportion to show their equivalence. Okay, so I'm going to show you here how we normally solve proportions. And the more we do this, it will get ingrained in you, and you'll hear me say the same steps over and over. So you know, like when we talk about solving equations, I always say when you see the word solve, you know your goal is to get the variable by itself. Why is it not by itself? And then do the opposite. Okay, so with proportions, I always say this. I say, what am I looking at? Well, I've got a fraction equal to a fraction. Well, we have a way to solve a fraction equal to a fraction. We're going to cross multiply and set those 2 fractions equal to each other. So when I say cross multiply, I'm going to multiply the numerator of this fraction by the denominator of the other fraction. So A times D would give AD. And then you do the same thing with the other fraction. So B times C would give BC. And when we cross multiply, we always set those 2 things equal to each other. And the benefit of that is we no longer have to deal with a fraction anymore. We just have an equation that looks like what we've been working on for the last several weeks. Okay, so looking at A, it tells me to solve the proportion. So I've got a fraction equal to a fraction. When I see a fraction equal to a fraction, I'm going to cross multiply and set those two products equal to each other. So x times 10, okay, x times 10, we want to write that as 10x. And then 4 times 9 is 36. And then we want to set those equal to each other. Fraction equal to a fraction, cross multiply and set them equal. Now I have an equation that we've been used to solving lately. So I want to get the x isolated. Well, why is the x not by itself? Because it's being multiplied by 10. How do I undo multiplying by 10? I divide by 10 on both sides. Keeps it balanced. 10 divided by 10 is 1. 1 times x is x. 36 divided by 10 is 3.6. So I find that the missing x value must be 3.6. If you want to, go ahead and pause the video and try to work these next two out on your own, and then I'll show you the correct way to do them. Okay, so looking here, I have 2 over 34 equals 5 over y. So again, a fraction equal to a fraction. I want to cross multiply and set those two values equal to each other. So the blue gives 2 times y, which is 2y. And then the red gives 34 times 5. That would be 170. And I set those equal to each other. Now I want to isolate the y. So why is the y not by itself? Because it's being multiplied by 2. How do I undo multiplying by 2? I divide by 2 on both sides. That cancels and gives y. 170 divided by 2 is 85. So my missing y value should be 85. Then the last one here is a little bit more tricky because we have a fraction. But we still, I'm sorry, not a fraction, but we have a decimal in the fraction. It's still two fractions equal to each other, so we do the same steps we've been doing before. We want to cross multiply and set those two things equal to each other. So I'm going to do the red one first this time. It doesn't matter which one you multiply first. I'm going to do the red one because I like my variable to be listed first. So 3 times n gives the value of 3n equals, and then 7 times 2.1, that would be 16.1. Now I want to get the n by itself. Why is the n not by itself? Because it's being multiplied by 3. So I divide by 3 on both sides. That cancels and leaves me with an n. 16.1 divided by 3 would give 5 point, and that would be 11. So that's 3, 2, so it's going to give 6, and that 6 should be repeating. So we would get n equals 5.36. Okay, so right here's our last 4 that we're going to be working. So I would say go ahead and pause the video and try to work them on your own. And then I will solve them and you can see if you did them correctly. Okay, starting with 6. I have k over 7 equals 32 over 56. So a fraction equal to a fraction. I want to cross multiply and set those two values equal to each other. 56 times k is 56k. 7 times 32 is going to be 320. 160. 160 plus 64 is 224. So you can just put that in your calculator, right? 32 times 7, and you would get 224. Now, I want k by itself. K is being multiplied by 56. So I'm going to divide by 56 on both sides. And that would give me k is equal to 4. So 6, the answer should be k equals 4. On 7, cross multiply, set those equal to each other. 39 times x is 39x. And then 13 times 18, that gives a value of 234. Now I want x by itself. X is being multiplied by 39. So I'm going to divide by 39 on both sides. And when I do, that gives me x equals 6. So my missing value here is 6. On 10, I have 6 over 25 equals d over 30. Fraction equal to a fraction, cross multiply, set those values equal. 25 times d is 25d. 30 times 6 is 180. And the d is being multiplied by 25, so I divide by 25. That gives me d equals, and then 180 divided by 25 is 7.2. So that would be the answer to 10, is 7.2. And then 11, again, cross multiply and set those equal. 6 times h is 6h. 2.5 times 9 gives 22.5. And now I want to get h by itself. H is being multiplied by 6, so I divide by 6. And I find that h equals 3.75. Or if you wrote that as a fraction, that would be 15 over 4. So either one on 11 would be correct.